Welcome to Lesson D2. In this lesson, I'm going to teach you how to use a multimeter, which is a tool used to measure voltage, current, and resistance. As your electronics projects get more complex, such as the robot you'll start building in the next lesson, knowing how to use a multimeter can be really helpful. In this video, I'm going to walk you through how a multimeter works and its various functions, and then in the next video, I'll show you how to use a multimeter to measure voltage, resistance, and current. A multimeter is a tool used throughout electronics for measuring voltage, current, and resistance. Some multimeters may also have additional specialized functions like testing diodes, transistors, or other electronic components. You may see multimeters referred to as voltmeters, but this is a legacy name or an old-fashioned name that started back when some devices only measured voltage. The term voltmeter and multimeter are often used interchangeably, but multimeter is the more popular term for the devices that have multiple measurements functions available. So let's briefly walk through the functions available on the multimeter from your Level D kit. So it has voltage measurement, both DC and AC, resistance measurement, current measurement, diode check, and transistor check. The voltage, resistant, and current measurements will be covered in the next video. The diode and transistor checking functions won't be covered in this lesson due to the complexity of connecting these devices to the multimeter and then interpreting the readings on the screen. But for more information on these functions, you can visit the Level D resources page on the 42 Electronics website. A multimeter has a rotating selector switch that's used to turn the multimeter on and off, as well as select the type of signal that will be measured. The multimeter runs on an internal 9-volt battery, so it's important to make sure the multimeter is turned off when not in use to avoid unnecessarily draining your battery. The multimeter has removable leads, also known as probes, that are used to touch areas of a circuit or components for measurement. These leads have handles with pointed tips to aid in touching only the specific component you intend to measure. You may notice that there are 3 jacks for leads and only 2 leads, and this is because the red lead will be connected to one of 2 jacks when making different measurements. The measurement taken will be displayed on the small LCD screen above the selector switch. Since there are a limited number of digits available on the display, the range selected will determine how accurately those digits are used. The range selected for a measurement will determine the highest and lowest values that can be displayed. Since the LCD screen can only display 4 digits, you must select a measurement range using the selector switch that will allow you to get the most information possible from those 4 digits. Now, when the range that is selected is too low, a 1 will be displayed in the leftmost digit, and this indicates that a higher range must be selected to view the measurement. When a range that is too high is selected, the reading will be displayed, but you won't be able to see much accuracy in that reading. Let's use an example of measuring the voltage of a single AA battery, which is somewhere generally between 1.5 and 1.6 volts for a fresh battery, or around 1.2 volts for a rechargeable cell. Your multimeter has voltage ranges of 1,000 volts, 200 volts, 20 volts, 2,000 millivolts, and 200 millivolts. And the AA battery can be measured using any of these ranges except the 200 millivolt range. So trying to measure a 1.5 volt battery using that range will result in a 1 being displayed, indicating that the voltage being measured exceeds the selected range. Here are the various degrees of accuracy that would be displayed for that AA battery containing 1.529 volts by using the other ranges. So the 2000 millivolt range gives us the best accuracy on this measurement, but this range cannot be used to measure voltages over 2000 millivolts, which is also 2 volts. 2000 millivolts equals 2 volts. If you wanted to measure your 3-volt battery pack, for example, that you were using in Level A, you would use the 20-volt range, which unfortunately loses 1 digit of accuracy over the 2000 millivolt range. Some higher-end multimeters have a feature called auto-ranging, which means it can automatically adjust the range based on the voltage that's being measured. This is a really nice feature, but it does increase the cost of the multimeter. It's generally 2 to 3 times the cost over models where the range must be adjusted manually. Okay, before you move on to the next video for this lesson, let's take a few minutes and we'll go over the few things we just discussed. The multimeter in your level D kit can be used to measure voltage, resistance, and current, as well as check diodes and transistors. The rotator dial on the front turns the device on and is used to select the type of range that you'll be measuring. The multimeter has 2 leads and 3 jacks. The red lead can be plugged into different jacks based on what is being measured. Okay, go ahead and move on to the next video for this lesson where I'll walk you through how to use the multimeter to measure voltage, current, and resistance.